Good evening, everyone. Thank you for joining us. This is the Greater Santa Fe Fireshed presentation on the ecological role of fire in the Santa Fe Mountains interactive webinar. I'm your host and chair of the Greater Santa Fe Fireshed Coalition, Porfirio Chavarria. Remind participants, that these landscapes that we are talking about in the Greater Santa Fe Fireshed are the ancestral lands of the Pueblo people and all the Native Americans that were here, in time between time immemorial. And I want to thank you all for joining us. Tonight's webinar is to learn about fire ecology across this landscape from the scientists who have been studying this area for the past few decades. A few housekeeping items. The format is we'll have presentations by 3 leading scientists, and then we'll have a facilitated question and answer period. Your participation in this is very critical, and you can participate through Facebook using the comments section. Please post comments there. If it's an immediate need, we'll probably we'll work to answer those as soon as we can. Otherwise, we'll grab those questions you post in the comments and we'll give them to the presenters afterward. The Greater Santa Fe Fireshed Coalition was formed in December of 2015 when the City of Santa Fe Fire Chief Eric Litzenberg and State Forestry Tony Delphine convened a meeting to ask if there was a willingness to work together to prevent a devastating wildfire that would affect Santa Fe. At the time, the city was working on a CFRP project to bolster the Wildland Urban Interface Program in education and outreach. The Forest Stewards Guild had proposed a fireshed map and project area, which became the now fireshed boundary. Let me show you that really quickly here. Let's see here. Yeah, so this is the fireshed boundary. And soon after that, the city and the county both passed complementary resolutions in 2016 designating this area as the fireshed. The fireshed's vision for this, the coalition's vision, is a landscape with healthy forests and secure water sources, communities in and near forested landscapes around that are fire adapted, with residents who take responsibility to reduce risks before wildfire occurs. Prepared communities feel secure and understand the role of fire in the landscape. Residents support treatments, including prescribed burns and managed fires, and accept smoke associated with fire management. Fire-using agencies provide well-coordinated, safe, and effective response to wildfires, strive to mitigate smoke impacts to communities, and resilient forests and thriving communities provide economic, recreational, and spiritual benefits for residents and visitors to enjoy. Now I'd like to introduce you to our speakers tonight. We have Craig Allen, Tom Swetnam, and Ellis Margolis, and I will go ahead and kick it off to them to begin their presentations.
Let's see, I need screen sharing privileges. Should be good to go.
All right, now.
All right, getting there, queuing it up. All right, how's that looking?
You're looking good there, Ellis.
Great. All right, thank you. Thanks for your time, everyone. And I'm excited to talk about a place that I've been working in for many years. But first, I'm going to introduce myself, Ellis Margolis. I live in Santa Fe, and I work for the U.S. Geological Survey as an ecologist. I've been working in these mountains since 1999, studying fire and forests. I'm probably one of the few people who have legally camped and or backpacked in the Santa Fe watershed, studying fires and forests, and it's been a great opportunity to get to know those mountains. And when I'm not working in the forest, I'm playing in the forests and out with my family doing various things, or the rivers that come out of the forested mountains as well. And the last thing I'll say is I love tree rings, and hopefully by the end of this, I'll convince you that tree rings are pretty cool. With that, I'll share a photo here, which is unfortunately way too common. This is the in medio fire of 2020. And again, just highlighting what we all have known and observed recently is that fires are increasing across northern New Mexico, across the Southwest, across the Western US, and even Western North America. So as you know, a common song may ask, well, how did we get here? And so I'm going to talk a little bit about what we know about that. So there is a long history of fire in northern New Mexico, and one of the ways we can understand that history is through tree rings, and particularly tree ring fire scars. So a fire scar is when forms when a tree is burned by a fire but not killed and is wounded, just like we have a wound. These trees will actually record those wounds as fire scars, and you can take a sample mostly from dead and down wood, and we can prepare this sample, sand it up, and then date the rings. And based on the pattern of the rings, we can usually date the rings to the year they formed, and then the fire scars often to the year they formed, and very often even to the season they formed based on when we know trees start and stop growing. Here is an example from the Santa Fe watershed, and the years marked are years when this ponderosa pine was burned but not killed, and recorded a fire scar here in 1664, the year 1685, and 1700. And so we're lucky enough in northern New Mexico to have some of the densest networks of tree ring fire scars actually in North America. And here you're looking at the Jemez Mountains to the left is the really big blob there. And if you can see my cursor, and then to the right, the bottom right is the Santa Fe fireshed area. And we'll zoom in to the Santa Fe fireshed. Here we're looking at the fireshed, the same map Porfirio showed with the outline of the fireshed, and all the individual dots are trees that we've collected over the past few decades to understand tree ring fire history. We will zoom into one of these clusters, one of the most recent collections that basically follows the ski hill road, if you will, from the Tesuque drainage all the way north to in medio drainage. And when you look at these records, from these ponderosa pine and mixed conifer forests, you see evidence of a lot of fires. So I'll walk you through this figure. On the bottom is a timeline, and from the year 1300 at the bottom left to the bottom right is out to the present. And each horizontal line is the tree ring record of a fire-scarred tree that we were able to date. And the vertical tick marks are the fire scars. And so you can see fire scars across the record, all the way back into the 1300s, and then coming out into the late 1800s. And when we have these records dated to the year, we can calculate things by how often fires occurred. And on average in this landscape that was sampled, every 6 years, there was a fire somewhere. And if you look at large proportions of trees scarred by a single fire, there were large fires in that landscape approximately every 12 years on average. But then, and these fires very likely looked like this. This is a photo of a prescribed fire from the Santa Fe watershed. These were very likely low severity fires, creeping through grass and needle litter, not killing the trees. Fire scar is unequivocal evidence of low severity fire because the tree has to survive the fire to record it. And so going back to the data, you see that this fire regime of frequent low severity fires stopped approximately 130 years ago. The last fire widespread was 1890, and then there has virtually been no fire since. The in medio fire that crept on the edge of the fire shed may have been one of the first relatively large fires. So it's been a long time, over a century, without fire. And with that removal of that very important process, then the forests increased in density. And we know this again through tree rings. If you're looking at this photo from the Santa Fe fire shed, which is very common. The orange bark trees we've learned through tree ring data are trees that are usually at least 100, 120 years old. And in this photograph, we know that those trees were alive back when these fires were burning. And so we can think about how dense the forest might have been. And you can too, as you're walking around in the forest, and especially with ponderosa pine, because they have that orange color, indicates, well, that's what the forest used to look like back when fires are burning. So if we count the number of orange bark trees we see in this picture, I'm seeing 4. And then benefit of the doubt, we'll give that down log a 5. And so in that scene, back when fires were burning in the late 1800s, you would have had 5 trees in the picture. And now we can count all of these blackjack ponderosa pines that are younger than that. And we've dated to much younger, and they've all came in after the fire stopped. And you get the point here. There are a lot of them. And in these landscapes where we've done the work and in other places across the West, densities of forests have increased 5 to 10-fold. And so a forest that used to have 100 trees per acre, widely spaced ponderosa pines, now can have upwards of 1,000 trees per acre. And essentially all of those trees that have accrued over the last century are energy. And when the forests burn again, that energy is released. And we see these unfortunate fires of today. This is a photo of crown fire from Las Conchas in the Jemez Mountains. One effect we see from these large severe fires that are highly anomalous are that they're killing forests that we know survive many fires for centuries, and they're killing large swaths of these forests. And we have multiple studies to suggest that they're probably not going to come back, in part because of regeneration limitations and lack of seed source. And a lot of these are coming back as shrub fields. If you ever are in the Jemez Mountains, an example of a place that's burned and reburned, there are places that were forests for centuries that are now shrub fields. And we were working in those all summer, and they're very likely not going to come back. This is a pattern that we're seeing in northern New Mexico, unfortunately. It's across the Southwest, and it's also occurring across Western North America as these fires are becoming more intense and larger than they have been in the past. Bear with me here, and let's take a little trip over to the Sierra Nevada mountains of California. This is an example, I think, that demonstrates these changing fire regimes and just the uniqueness and incredible nature of how these fires have been killing forests these days. This is a giant sequoia. If you haven't been there, go see them. They're incredible trees. Put it on your life list. And a sobering statistic that has come out of work at a giant sequoia from colleagues of the Park Service, that 13 to 19% of the large giant sequoias on planet Earth were killed by fire in the last 5 years. The last 5 years, right? I read that, and it just kind of struck me to the heart. And this summer I said, you know what, family, we're going to see these giant sequoias. So there's a photo of my kid out there. It's just amazing. And to me, it's indicative of the changing fire regimes and the severity of these recent fires. You'll see from this is work that Tom Swetnam, who will be speaking next. He pioneered tree ring dating in giant sequoias, and many of these trees survived upwards of 100 fires over multiple millennia, and they're dying. These same trees are dying now in modern fires. It just goes to show how much the world has changed and how severe the fires are in these places, again, from the same process, the increased density after we stopped fires. So the bad news doesn't end there. Unfortunately, as we've experienced after all of these fires come the floods. And here's some photos from northern New Mexico. And bottom one, the upper right is from the Gila, and the left is from Bandelier, where we've had these severe fires and then the flooding. And the photos, the circles, there are people, just for scale, and these tiny little creeks that normally you can jump over. They're increasing their flows by 10 to 100-fold, and creating these giant log piles that look like something a dinosaur beaver may have created. But it just shows the power and the change of these systems after these fires. You end up with these horrible floods. Here's a little video. This was from Flagstaff, who had that bad fire this summer, and then flooding thereafter. demonstrate what happens. And again, this is all too common. Just normal monsoon rainstorm on these denuded landscapes, and you get scenes like this. So these remind us that forests, fire, and water supplies are connected. And as I'm sitting here in Santa Fe, it's important to remember that right now a third of the water for Santa Fe comes from this forested watershed. This is a photo of the Santa Fe watershed. And so with that in mind, working with the city of Santa Fe and thinking about the potential for post-fire flooding and debris flows, we've just, we're wrapping up a study looking at modeling fire and debris flows in the Santa Fe watershed. And here you're looking at 3 fire severity scenarios for a low, moderate, and high severity fire. And we use these to plug into debris flow models to understand the debris flow potential in the Santa Fe watershed. The colors here, yellow is a low severity fire. Again, this is a fire, these are fire simulations, and orange is moderate severity fire, and red is the hot fire, and orange and red are those tree killing fires. So one thing you can see are these yellow blocks, and I've highlighted the areas that have been treated. Those are modeled to be lower severity in the low fire weather fire. And even percolating all the way through to the high probability fire weather scenario on the far right there, you still see some benefit of treatments to lower fire severity. And then that translates to the debris flows. So fire severity is strongly linked to debris flow. And so here you're looking at a 3x3 scenario of those fire weather scenarios on the left. And so the 75th percentile is that low severity fire, 90th percentile fire weather is that moderate, and then 97th is the high severity fire. And then we paired that with 3 rain events and a 2-year return interval rain event. So, relatively common, 5-year, and then a very maximum rain event. And so that's the 3x3 you're looking at. And one thing that we can see is that from the results, if you pull a moderate severity fire plus a moderate rain event, you get estimates of over 1,000 acre feet of debris. That's approximately 30% of the capacity of the reservoirs. And again, that's just from a moderate rain event with a moderate severity fire. These sort of events would potentially have effects on dam operations, of course, water quality, like we saw over in Las Vegas and Guyanas, and extreme scenarios could fill both reservoirs with sediment. One thing to note, again, those reduction of fire severity from treatments, they also play out in reduction of debris from post-fire debris flows, and the blue arrows are pointing to basins that were treated, and you see that lighter color, and they're adjacent to basins to the right that were untreated. And so again, we have reason to believe, and there's experiential evidence that these treatments, basically reduction of all that fuel that's accumulated over the last century, would reduce fire severity and then ultimately reduce debris volume. And with that, I will turn it over to Tom.
Okay, hello everybody. I'm Tom Swetnam, and this is a very much boring introduction compared to Alice's wonderful slides of his family in the watershed and elsewhere in New Mexico. I just want to introduce myself a little bit and tell you a little bit about my background. I'm not going to go into any of the details on this, but just wanted to mention that I am a native New Mexican. I grew up in New Mexico. Went to grade school in Penasco and high school in Jemez Springs, and my wife and I retired here to Jemez Springs back home about 8 years ago after living in Tucson for 35 years, where I was a professor and a director of the tree ring laboratory. And before that, I was a wildland firefighter for 3 seasons in the Gila Wilderness in New Mexico. And that was a really formative experience for me to see fire on the landscape, low intensity fire burning naturally in the wilderness. And I had experience of high severity fires in as a hotshot in Idaho. So it really affected my understanding of fire and fuels, and especially the importance of driving fire regimes. Over the last 40 years or so, I've been fortunate to work with people like Ellis Margolis as a graduate student, and now a leading scientist, and others, and studying forest and fire regimes across Arizona and New Mexico. And we've basically done fire and forest histories now over almost all major mountain ranges in northern New Mexico. And I also had experience working on mixed and high severity fire regimes in northern Rockies and Siberia, Russia. I tell you all this just to point out that I understand, and we've had a broad perspective of fire regimes across elevational gradients and across different regions, and we understand what high severity fire regimes look like in the paleo record, and we understand what they look like today, and our interpretations of high severity fire and low severity fire in the context of fuels is based on really broad experience. The other stuff are just some accolades that I won't go into, but if you want to learn a little bit more about me and where I'm at and where I'm coming from, a personal perspective, this is a picture of where I live. Actually, this is the Jemez Valley, Jemez Canyon, Jemez Springs down canyon there. And there's a video interview of me by Laura Pascas, excellent environmental reporter, a few years ago. And the title of it is Preparing Homes for Fire Season. So it's an online video, and there's about a 15-minute video there, and you can see how we're trying to deal with this very dangerous situation that I live in, that I've chosen to live in. This is the Wooey. This is a one-way road coming up to my house in my neighborhood, very steep landscape with lots of fuels. And I wouldn't have moved here if I didn't believe that we can mitigate high severity fire risks by doing forest treatments and reducing the fuels. And it's not just about the Wooey and the risk to home. It's also about risk to water. This is the water supply that's about 400 yards from my house upslope. And this water supply is about 2/3 of the water for Jemez Springs. And we could lose that in an afternoon with fire running up these slopes. And so we've been working to try to treat around these water supplies, and also with the Forest Service on adjacent properties. And really something must be done, because if we don't, it's just a matter of time. So here's the main points I want to make over the next few minutes. That is, we've learned a lot. This is about looking at the past and understanding the changes that have occurred in these landscapes. And Native Americans, Puebloan people, especially the Jemez people and the Tewa people of the upper Rio Grande around Santa Fe, and Spanish and American colonists greatly altered these woodlands and forests in many ways, especially around Santa Fe with its long history. Fuel wood gathering, timber harvesting especially, and what we see with historical record with tree rings and photography and other sources, that removing the fuels reduce the extent and severity of fires in ponderosa pine. And we also learned that these land use practices actually buffered the climate fire response that we typically see over the Southwest. So I'm going to touch on each of those major points here in the next few minutes. But first, this is a kind of an image of the Jemez landscape with the very big villages that existed here on the mesa tops above Jemez Springs. And this is the interesting situation where people in large numbers, thousands of people living in woodlands and forests for hundreds of years. How did they do that? How did they not burn up? Well, long story short is people used fuels. They used the fuel woods to burn in their hearths. And so all around the villages, there were very few trees. I'm actually hesitant to show this picture on the right, this artist rendition, because it does show cleared around the village. But in fact, up to a half a mile or a mile away from these villages, there were very, very few trees growing. And we know that from the extensive tree ring studies we've done around many of these big village sites in the Jemez in the last 10 years. And there's a lot to this, and I'll give you a link to some of the papers in a minute. But some of the basic take homes that we've learned is that, you know, the fuels have built up because of the lack of fires, the lack of spreading fires, and the lack of people removing small diameter trees for fuel. and for vigas for their houses. This is a ruin. This is one of the ancient ruins up above Jemez Springs. A photograph in 1900. The trees have already started to grow in up next to the village. And by 2015, that's actually me standing in the same place that this guy is standing, the same ruin. Trees have grown onto and around the village. And a consequence of that is that wildfires burning in the Jemez now are burning over these old villages that we have no evidence of high severity fires ever burning over these villages in the past. There's no archaeological evidence. There's no ethnological, verbal stories or legends of towns being burned over. But now these sites are burning with high severity and actually damaging the archaeology, ruining some of the pottery and the lithics, and even the room building blocks are spalling from the heat. Again, there's multiple papers we published in the last 10 years on this topic, and including proceedings of the National Academy of Science in 2016 and 2021. And just a few weeks ago, this paper at the bottom we published looking at the influence of intensive land use by people, Native American people, Puebloan people, on mitigating and buffering the effect of climate variability on fires, and actually having a mitigating effect. So I'll talk about that in a minute. Here's another paper that talks about fire and climate in the Jemez and people. If you'd like to receive any of these papers, send me an email. There's my email address, treering1748@gmail.com. And you can also visit that website there and see a lot more information about these studies of people and fire and climate, and how people interacted with fire and lived with fire for centuries, literally centuries. The study just published a couple weeks ago, looking at climate and fire linkages in the Southwest, is drawing on a very large network of sites, more than 180 sites across Arizona and New Mexico. And what we did was we looked at how the big fire events were related to drought. And what we find typically over the whole region is that fire years occur during drought years, the dry years shown here on the lag year 0. And typically 1 to 2 or 3 years of wet conditions occur before the fire year. So in New Mexico, it's like El Nino years produce wet conditions and reduce the fire activity. And then you hit a La Nina condition like we have the last 3 years, that's when things burn. So this wet-dry switching has been operating for centuries in New Mexico. But interestingly, when we zoomed in to particular landscapes where there are lots of people during certain time periods, in the high intensive use periods, that linkage fell apart. There was much weaker connection between the wet-dry switching. So in other words, people buffered the extreme variations of climate, telling us that, you know, if you use fuels and you burn it with surface fires, or you use it in your hearths, you're going to reduce the extent and severity of fires over the landscape. The last little part of this talk is about changes around Santa Fe, especially with the photographic record. You know, this is Santa Fe, of all many of the villages and towns in northern New Mexico, is one most heavily inhabited for hundreds of years, at least 400 years, and longer if you consider the Tewa people living here with their pueblos nearby. But one of the impacts of people living on a landscape for hundreds of years without, you know, electric heating or gas heating, is that you have to use fuel wood. And so you just do the numbers of cords, the amount of cordwood that had to come out of the forest up to 10, 20 miles, 30 miles away from Santa Fe. It's huge. One of the common photographs you'll see in the photographic archives of the Palace of the Governors are dozens of photos of burros carrying fuel wood into Santa Fe, and also latias and vigas. So on the right here, you see these vigas on the ground. I've been doing tree ring dating work in Santa Fe and elsewhere around northern New Mexico of old haciendas and churches recently with my colleague Tom Wines with the Park Service. And we would look at the dates of the timbers. We determine when these timbers were put in the roofs. And it turns out many of the old haciendas and churches, they've had the roofs replaced many times because these old adobe houses, the roofs rot out and they have to be replaced. The bottom line story is that many trees were cut for fuel wood and vigas and timbers for 400 plus years in Santa Fe. And as a consequence, the landscape looks really different now than it used to for hundreds and hundreds of years. Here's an 1866 photograph And you can see there's the St. Francis Cathedral and the foothills in the background there. There's virtually no piñons in the lower foothills, where now you have dozens or hundreds of homes, very valuable homes, I might say, in the foothills of Santa Fe there, and big open patches on the forests above. And here's a view a little bit further to the west in the 1880s. And here's a bird's eye view map of Santa Fe from 1882. Again, look at the foothills looks like in this bird's eye view, which reflects what's shown in the photos. Here's the Santa Fe River coming down out of the watershed. The bottom line is that we've got huge changes, and people, this is what we call the shifting baseline syndrome. I think there's a lack of perspective that closed canopy pinon juniper woodlands, I actually like them too. I like to have a very robust pinon juniper woodland around my house too, but there's consequences for having continuous fuels over these landscapes. And what you have today is not the way that it's always been. I'm not saying that we need to go back to this kind of an overused, over-harvested landscape, not by any means, but lower density forests and woodlands would be a very wise a thing to do in the context of climate change and the fires we're having. So just a few more slides of the watershed. This is the McClure Reservoir, and you can see this 1926 photo. You can actually see some snow on the ground, the open stand conditions compared to the more closed stand conditions today. And here's another one from 1916, again, overgrazing and overcutting in the early period, resulting in erosion. And, you know, the proposed thinning for the watershed and surrounding areas is nothing like that. It's more like, can we open up stands like to look more like that, rather than this kind of closed stand condition, much more sustainable from a long-term perspective with fire regimes. This is one of the great aerial photography comparisons in one of Ellis's papers that shows the watershed on the left in 1935. There's an airplane flying over the watershed, and you can see a lot of ground there. There's a lot of, you know, grassland and interspaces between the trees compared to 2005. The bottom line is that we've greatly increased the connectivity of the fuels in the last 100 to 150 years. In fact, these changes are nothing. And what we've got now is the most continuous canopy coverage of woodlands and forests in at least 400 years. And summarizing, you know, prior to European colonization, the fieldwood gathering and small tree harvesting and setting small fires served to reduce wildfire extent and severity. We've published on this repeatedly, and this is what we find. When people use fire on the landscape, small fires, you know, we don't get the high severity fires. And then, you know, again, overgrazed and overharvested forests are not what we're trying to aim for. On the contrary, but reducing current forest density and fuels is going to reduce the likelihood of wildfire extent severity and mitigate the effects of extreme climate variability. Finally, fuels do matter. As an ex-wildland firefighter, it kind of makes my head spin a little bit when people say that it's just all about climate change and, you know, the warming temperatures is driving all of it. No, fuels and climate are important. In fact, fuels are maybe more important when climate warms up. So dealing with the fuels is a reasonable approach, in my view. I'll leave it there.
Thank you, Tom. And now we have Craig Allen. You can see your screen there, Craig, and I think we can hear you now.
Yeah, okay. Thanks. Sorry. Forgot to turn on. Great. Yeah, well, thank you. I'm gonna close the presentation part, and I'm not gonna really discuss this slide, just there's some background information here, but the main point to know really is it's been my pleasure really to have had the opportunity to spend my adult life here in New Mexico. I grew up in Wisconsin, but I've spent my whole adult life out here living and working primarily actually in the Jemez Mountains side of things. This will be the 43rd year in a row I'm doing field work here, coming up in 23. Based out of the Jemez side. Let's see, what do I need to do here to make these move? Oh, there we go. But you know, I grew up part of a big family in Northeast Wisconsin. When I was a kid, Grandpa bought a little swampy 40-acre woodlot about a mile from the farm, the ancestral farm he grew up on. And that's, Dad taught high school biology, and I didn't even know it, but that's what I was doing, learning without training. It was sort of how to read the landscape, understand the history of a landscape that had been really worked hard by people for a long time. And it turns out I've spent my whole adult life in this landscape. Since 1981, I did both my master's and PhD in this landscape, studying landscape change. Forest change is part of that. Fire is part of it. I started working with Tom for sure as early as '84. I don't remember, but because fire was such a clear driver of all sorts of patterns on the landscape, certainly including vegetation. I did that work, and I've been based continuously since the 80s out of an office in Bandelier. I retired as a research ecologist with USGS almost 2 years ago. But I started with the Park Service till they moved the researchers out in 1993, at which point started a field station, the Jemez Mountains Field Station. We're a field station of the Fort Collins Science Center of USGS. Ellis runs that field station now. But prior to that, through 83, from when I finished dissertation, from 89 through 93, I was working directly for the Park Service for Bandelier as an ecologist. And job one was setting up monitoring and baseline studies of this little park unit, Bandelier, that had had all this archaeological work done, but not very much ecological stuff done. So we have put together an amazing amount of work. It's kind of like a little mini long-term ecological research site. Kay Bealey there in the hat, we've been working together more than 30 years. I actually volunteer for Kay now, where we've got loose ends, so many data sets, but we've looked at the web of life, everything you can imagine. We've done something on, from inventories of, well, you name it. And as we, starting in 2000, Kay and I helped. Tom was on the board of trustees for the Vice Caldera when it was acquired in 2000. And for 2 years, we helped set up, basically, we set up the initial baseline and inventory monitoring and science programs for the caldera as well, that Bob Parmenter has taken and run with. So we have, from the Rio Grande to Redondo Peak, the big peak in the middle of the caldera, this elevational gradient of countless kinds of studies on, you know, everything from soils and hydrology and herbaceous plants and woody plants. Almost everything you're seeing here are various kinds of veg plots. Tree growth, insects, avifauna, mammals, big and small, lots of things. The thing, when these studies were set up, the ones in Bandelier in particular, I arrived in the 80s. From 78 to 95 was a relatively wet period, and it was a great place to be a tree. Forests, the snowpacks were abundant, trees grew well. That changed in the late 90s, and this is a footprint of fires on top of this. And so part of the power of this network, we are continuing to learn from all these long-term studies, these baselines out there. So we got it when the good times were rolling through the 80s and early 90s, when it was cooler and wetter. And now we're seeing the difference now that we're in this mega drought. And so much of the last 20 years of my career has been looking at these kinds of tipping point changes, first here in northern New Mexico. And then as time went on, we were kind of an early harbinger because it hit New Mexico, northern New Mexico, the Jemez hard in the early 2000s. And scaling up to Western North America through research networks, and then eventually even globally. So I'm going to give you sort of just looking across the valley, straight across here at the Jemez. Here's some of the things we've learned. And things that are applicable, we believe, to similar forest types here on the Sangre side, on the west flank here. Temperature, there's Park Williams was postdocing at Los Alamos, found a temperature signal in the regional tree ring record that it turns out that that warmer temperatures really have a strong effect, a negative effect on tree growth in this region, on conifers, trees, and increased tree mortality processes. All of these are temperature-related forest disturbances, and we sort of knew that, but the signal of it was stronger than people knew prior to some of the work in the last 20 years. And so this has been sort of a big point of research, is all of these things, including fire, but not just fire, particularly the physiological drought stress and die-off. It amplifies insect outbreaks, not just because the trees are stressed, but also directly affects the life cycles. They can get more generations in a year. And what we've been seeing is that the warming has driven increased tree mortality from 2002 to 2004 all across the Four Corners. Millions of acres of multiple trees died all up and down the elevational gradient. These were piñones, pretty much the Bandelier, Los Alamos area, mature piñones, 90 to 95% went down in 0203. But all the way up the gradient, up to tree line here in the Pecos. These are recent photos, drought stress trees in this mega drought, which now appears to be the based again on the treeing records. Park Williams, who did that early work, has published in the last 2 years that it's now the most severe drought in at least the 1,200 years that we have a long enough treeing record to assess it in terms of stress in the system. And 30% of that is due to warming. So yes, of course, there's a precipitation deficit, but the warming is amplifying, it's aridifying the whole system. Ecosystems up and down from the deserts to the subalpine to the alpine. This tree mortality, and it was affecting grasses and shrubs. We've documented it, it killed, in 2002, it killed 2/3 of the grass cover in the pinyon juniper woodlands in Bandelier on our long-term transfix there. It's killing trees by the first decade of the 2000s, all across Western North America. Similar things were emerging. And it turns out, scaling up, working with literally in the end, hundreds of colleagues the last 15 years, this stuff is going on globally. And it turns out, for instance, the modelers, we know how to grow trees reasonably well in models, but we can't kill them realistically yet. Barely even single species, but working with many colleagues, we've pulled together the patterns at a global scale, and have been working on trying to understand the processes underlie it and how vulnerable are the world's forests. Anyway, this has been a big point of work, but it was based and grounded in the work starting here in northern New Mexico. One of the things, unfortunately, sadly, for those of us who care about these incredible charismatic megaflora of big old trees, ancient iconic trees on the planet, is that they are disproportionately vulnerable to hotter drought stress, both in terms of its impacts on their growth and into their vulnerability to mortality from various processes. And that's true. Warming is bad news for big trees on planet Earth, including here in northern New Mexico. Same things are going on here. Big old trees matter. One could talk a long time about this. It's something I've been working on a lot, about these kind of ancient iconic trees in recent years. There's many, many values, from very specific biodiversity values associated with it, many other ecosystem services, the scientific values you've seen demonstrated today, the global carbon balance, the largest 1% of trees in old growth forests globally, the largest 1% by diameter in all forest types averaged around the world, millions of trees in that data set, the largest 1% by diameter sequester half the above ground carbon. Big old trees are so important to the global carbon balance. And of course, we care about them for many reasons. And even their intrinsic value, these magnificent beings deserve to exist and not be killed by our actions. Anyway, fire size and severity are clearly, I'm going to shift off of the die-off stuff now to fire size and severity increasing.
Hey, Craig, real quick.
Yep.
We have about 2 more minutes left for your
All right,
presentation.
let me roll then. I'll go through the HEMAs quick to get to the Sangres. In the HEMAs, we've compiled the maps for the first 70 years of the fire record. There's the caldera, and boom, these are by decade. That's the Las Conchas and Thompson Ridge fire. The fires are getting bigger. It isn't the size of the fire, though, that we care as much about as the severity. The whole east flank of the HEMAs has pretty much been converted and lost at this point. From from a conifer tree standpoint. There are things growing in there. Ellis talked about it, but shrubs and herbaceous plants at lower elevations, certainly things like aspen at higher elevations. Down in the woodlands, we're not even sure what's going to come back. This is so out of the box down there without precedent. And then the watershed stuff, I won't address that any further. Ellis did it, but I will just say things like the Las Conchas fire triggered from Santa Clara, every canyon on the east flank, from Santa Clara wrapping all the way down to Cochiti. Every one of those canyons had, after Las Conchas, had high severity floods and debris flows. And we've been studying this recently in the streams of Bandelier, in these canyons, which were linear oases, and they were basically sterilized. The aquatic invertebrates were wiped out. We've lost, we think, at least one tree species, maybe two, from the whole park. Arizona alder, beautiful tree, one of my favorite trees. Anyway, huge impacts in the ecosystems from the riparian zone to the uplands. Lots of things could be said about that. What does it look like on the Sangre side to close this out? Similar, if you look at the record of historic fires, it's ramping up here too. So this is through 1999, the historic fires in the southern Sangres. There's adding the decade of the 2000s, and you can see the footprints getting larger. Here's the 2010s. Here's the first few years of the 2020s. And of course, now the Sangres have had their mega fire, Hermit's Peak, Calf Canyon, which is having similar kinds of impacts to private and public infrastructure that we don't need to talk about, but the impacts of these things, we're talking billions and billions of dollars. That same vulnerability, I would just note, exists here. That little dashed area is the fire shed. And you'll note there's almost no fire activity in there yet. All of those fires here in the middle, those are actually the prescribed burns in the municipal watershed. But much of that is just waiting for an ignition on the wrong day. So in closing, I would just say that there's just an abundance of robust, diverse, this is just the tip of the iceberg of, there's literally hundreds, if not thousands, of different kinds of ecosystem studies done here in northern New Mexico in the last 40 years. And there's a lot of vulnerability. We see those patterns, but we do know there's some things we can do. These simple proven management treatments of thinning the small trees from below and then reducing the fuels with managed fire, which obviously has to be done skillfully. But we can improve the resilience of our forests and our big old trees. If we care about the big old trees, no action is a death sentence to them. And I would just say that there is hope. These are worrisome times. These systems have been in the process. This is what we've been documenting. They are of necessity, are resetting themselves. They're restructuring, reorganizing under the face of these climate stresses and the stresses from these land use densification processes. But there are hope, but we do need to act with some urgency. You can see, we all can see how rapidly things are changing. We need to work together collaboratively. We're going to need to continue to learn because there are many surprises. We could have given a lot of interesting talks about what has surprised us moving along. And so we need to continue to learn. And with that, we'll get to questions. So thank you.
Thank you very much, Greg. Appreciate that. I'd invite Greg, Tom, and Ellis to go ahead and show their video, and I'll go ahead and just hand out questions, and we'll see where we end up going with them. I'd say feel free to kind of let me know who wants to take them, or just go ahead. The first one that we got we are still experiencing some very, very windy days and big gusts of wind at times. This must be taken into account before any control burns are done. How can we be assured that the Forest Service makes this a high priority in decision making? Now, I want to say none of us here work for the Forest Service, but how can we perhaps guide them in creating priorities in their decision making regarding how these control burns are done?
I'll chime in a little bit. At first, as Porfirio said, none of us here are Forest Service. None of us here currently work in fire. And so, again, I don't think we have a say in that question particularly, but I will say that understanding the processes of the Forest Service, they have rules, regulations. Those are now increasingly scrutinized. There will be a follow-up talk by the fire manager from the Santa Fe, is my understanding. And so I think that those sort of questions, Porfirio, and to whoever asked that, will be addressed by Santa Fe Fire Management. And again, it's my understanding, if people haven't read, there are now 7 additional rules that need to be boxes that need to be checked came down from the Chief of the Forest Service for prescribed fire. So there is clearly increased scrutiny on prescribed fire, again, given some of the recent events. But I don't think any of us have the knowledge to address that question. But please chime in. I'm excited to hear what the Forest Service has to say about new rules on prescribed fire. And that I think that webinar should be coming up in January from the fire shed.
Yeah, thanks, Elsie. Yeah, my understanding is, the Chief of the Forest Service did a review on the prescribed burn program across the country, created those 7 kind of recommendations, sent those to all the forests. The forests need to address those. And my understanding, the Santa Fe National Forest has reviewed those and addressed them and sent their implementation plan or whatever it's supposed to be called. I don't know what their process is exactly, but has sent that to the regional office for their review and approval. And then I believe that goes to the Washington office to the chief to review and approve before that comes out. So I agree. I think in January or whenever they're ready to prepare what they've decided that's been approved that they can go forward with their burn program is going to be presented in a similar format here, maybe even perhaps in person. The next question I have is, if grazing and logging were allowed, would it limit some of the fire damage if we had more grazing and more logging, I guess? And there was a similar comment towards that as far as, and I'll read that as well, related to this, where there used to be a number of sawmills in southern New Mexico that kept a lot of the mountains there cleaner. There were also a number of permits that were pulled that grew a tremendous amount of fuel because no grazing or logging were happening on those areas. The fuel was a driver in the black fire. Looks like grazing would have taken care of part of that problem. I see the Forest Service pulling all these permits all the time for no more logging, and it's all done under the guise of saving something or other. And it doesn't seem to have worked very good. So it's all along with that grazing and logging kind of thought. Would that help?
Well, I'll just chime in. In my perspective, the problem is not the lack of logging. I mean, the problem is that we have too many small diameter trees, and it's the problem of dealing with small diameter trees, and they don't fit. They're not the saw logs. They can't produce boards. I mean, you can get products out of them, but they're more expensive. In the end, what I see is we need an investment in our forests. We spent, the last 100 years plus pulling big trees out of many of these landscapes, and now's the time to reinvest in these landscapes and remove small diameter trees. Sure, you make some products out of them where you can, but in the end, it's going to cost to do a lot of this thinning work and prescribed burning, but it'll save money in the long term. It's much less expensive to do the thinning work and prescribed fires, reintroducing fire, than it is to put these fires out, and the damages that they cause are in the hundreds of millions to billions of dollars. If we'd spent that amount of money on actually investing in the forests, we would have prevented these high severity fires in the first place. And so again, it's like I don't see that increasing large diameter tree cutting is not the solution at all. We need to deal with small diameter trees, right? Grazing, livestock grazing can reduce the spread of fire, but it has to be pretty intensive to do that. So I don't know how many places we can actually graze to that intensity, and there's consequences of over intensive grazing as well. So yeah, I mean, there's a role for multiple use of our landscapes, but in the end, right now, I think we need a big investment in our forests to prevent them from burning catastrophically and converting to shrublands and grasslands.
I would just say one more thing about the grazing, which is that the forests, the sort of overdense dog hair thicket kind of forest, there's nothing to graze for the cattle underneath. The herbaceous part of the system's been squeezed out by this woodification over the last century plus. So the livestock grazing did actually, our best understanding, the tree ring record, it's pretty clear. It actually, the surface fires stopped in the late 1800s before active fire suppression was even an institutionalized policy, or there were hardly any resources, but it's because it was open with grassy understories. And so the livestock grazing, it's effective in those kinds of systems. But in the stuff like in the fire shed here, the systems, these dry conifer forests that are overgrown, grazing wouldn't have any effect, and the cows wouldn't stay there. they would move because they would starve. So.
Thank you, Craig and Tom. Let's see, I'll keep moving down the hill. This is a question for Ellis about William Baker's study in 2017, analyzed the map you presented of composite fire intervals in the municipal watershed and found them to be inaccurate. I don't know if you have a response to this, or if it's best to, or maybe there's a, I don't know if there's a short answer. Ellis?
Yeah, the short answer is that I actually did not show Santa Fe watershed data. The little bit longer answer is that there are multiple studies that show that tree rings can very well replicate known fires, and that these records are not biased, and that if you hold a piece of wood in your hand from the Santa Fe fire shed and it says it has 10 fire scars on it, then no sort of reanalysis of the data is even needed. That it's clear there was historical fire, they were low severity, and yeah, I'll end with that.
Thank you, Ellis. Let's see, I don't want to go through these. I'm trying to get to all of them. I don't know if I will get to all of them, but is the Santa Fe ski area in danger from fire? Why? The Santa Fe water supply, is that in danger? Is the Santa Fe economy in danger? And why?
I think that's you, Ellis.
Sure, I'll share screen here a little bit again, touching on the question about the Santa Fe ski area. And again, we have some information here. Let's see, let me get that in full. People seeing that? So this is a photo of the Santa Fe ski area in the early 1900s. And so the tree ring records I talked about and the fire regimes I talked about are from that middle elevation zone of dry conifer forest. And once you get up to the spruce fir and up into the aspen, there's a different type of fire regime, and it's basically crown fire, meaning that it burns to the ground, the aspen resprout, and then there's a successional cycle where the spruce and fir come in. And so that's what historically happened in the upper elevations. Here is the retake of the Santa Fe ski runs, which many people on the call probably know, but that's an old crown fire patch. And so the data do not suggest that it's at all the same story I talked about with the tree ring fire scars. This is a different fire regime. We've got data, we've got papers on this. I'm happy to share that. And so any sort of management prescribed fire is not would not be informed, recommended by the data in this type of fire regime. These burn to the ground, and you just need to be prepared for when they burn. You get out of the way because they're large, severe fires, and there's not much to do about them. And so a very different fire regime. And yes, the ski area is potentially at risk. And then the upper watershed of the upper portion of the Santa Fe municipal watershed is spruce fir. And we know that last burned in the year 1685, and it burned in a high severity fire that burned most of the forest down. There are no fire scars when we were walking around in that forest, we found no fire scars in the spruce fir zone. It's a similar forest type as this one you're looking at here, those highest elevations. And there are, to my understanding and my recommendation based on the data, there are no treatments proposed in those upper elevation systems. They're a different type. And so again, our understanding of the fire ecology of the system is useful in thinking about whether there have been changes that are outside the historical norm in those upper elevations. It's very likely that those are more similar and will burn similarly to the way they used to be. And there's not too much you can do about it. Whereas if you move down into that middle zone that we talked about, that's kind of the sweet spot where the ecology of the system and the changes are something that people can potentially, alter the fire regimes, and the evidence that Thomas showed. That's where people were living. The Jemez were living at, 7,500 feet in those pine zones. They weren't living up in a spruce fir forest, probably because they knew better that they'd get roasted, right? And so again, I think that's where understanding the fire ecology is important to think about potential management.
Thank you, Ellis. This is probably one for you as well, possibly. I think you talked about this, but could you reiterate, how do we know historic fires didn't burn at high severity?
Yeah, that's a good question. And so like the photos I just showed, when you have high severity, you kill the forest, right? By definition, you kill large patches of trees. And so when you go in and look at the ages of the trees, like we've done up in the ski area, you see a very even age forest where there's a cutoff, no trees have survived, and then the aspen especially resprout. And so we have data, and we know what tree ring data and forests look like in those high severity systems where you have often younger stands, and then there's a threshold, and there are no fire scars. And so again, we spent weeks walking through many of those systems looking for fire scars, and they don't exist because in those upper forests. Whereas if you get down into that middle band, the ponderosa pine and the mixed conifer, you find fire scars everywhere. You can't walk around without finding. And again, a fire scar by definition is unequivocal evidence of low severity fire at that point. That tree survived the fire to record a fire scar. And so, and then we have networks. We have large networks to understand what happens in between. And so the best evidence we have is that, especially in the ponderosa pine zone, you don't find large patches of young trees. You find fire scars everywhere. As you move up the elevation gradient into the mixed conifer, again, we have a paper that goes from the ponderosa all the way to the top, from low severity fire regime to high severity fire regime. And in that middle, you have, in the mixed conifer zone, you have maybe a mix of low severity and high severity. And in the Santa Fe watershed, in that mixed conifer zone, in the bottom part of the wilderness, we found little patches of high severity where a fire in 1842, it killed that little stand on the north slope. And then it dated all the trees, and they all dated after that. And so there are ways, and we have data to show where we think there was historical high severity fire. And that's in those more productive systems, the higher, wetter as you move up the mountain. In those lower systems, we just find no evidence of it. And again, we've been wandering around in these places for 20, in Tom and Craig's cases, 30, 40 years. And the preponderance of the data shows that there's fire scars everywhere, and there's no evidence for those large high severity patches like we do see have evidence at the higher elevations.
And one more question towards that high elevation is, do you think that higher elevation stand replacing fires are larger in scale and less patchy now than, say, 300 plus years ago?
That's a great question. This is, and so when I suggest that those systems in the higher elevation systems are behaving more like we think they did historically, this is actually the one place in terms of patch size. How big were the patches of those high severity fires? And that's the one place where there is a little bit of data suggesting that maybe now the patches are larger because there are huge carpets of forest that can burn all at once, and that historically there may have been more of those patches to break up the kind of the carpet of fuels. And so, but those data are hard to get at because what happens up in upper elevations is you have a patch of forest that gets killed, and then another patch burns over it, and all of a sudden that record starts to go away. And we did our best to try and understand the size of those high severity patches, but it's a really a challenge. And so, but I think there is some evidence to suggest that the higher elevations, that those patches may be getting larger because it's more homogeneous. There aren't different stand ages. And then clearly now the fires can run in a crown fire from the PJ all the way up to the top, right? The bottom of the forest all the way to the top, because there's a carpet of fuel, like Tom's repeat photo showed, that there's no discontinuity in the fuels, that there's just a carpet. And so you can have crown fire across the whole system. And again, when you combine those different forest types, those patches are clearly larger in the lower end. And then when you combine them with the upper end, those patches are clearly much larger across the gradient than any we have records for.
Thank you. And I'm not clear if we have, I know we're past kind of 7 o'clock and that's kind of the time we ended. We're welcome to stay for a bit if there's any other questions, but I don't know if we're seeing any more on the Facebook side of comments. All right, so one more. So since climate is changing, why should we be focused on these historic densities and historic fire regimes? Since we're, is that still applicable to try and move towards that?
Sure, I'll take that. So, we use history now to just understand how we got to the present, and as a guide in some way to how we might operate in the future. And fire history has shown us that there's been wide variations in forest densities and fire regimes over time, but overall, climate and fire are very closely coupled. And just an example I would give of where the past is still useful for understanding the present and maybe aiming toward the future are the giant sequoia groves. We had 3,000 years of fire history from fire scars there. And over that 3,000 years, there's a period known as the medieval warm period or the medieval drought period. This is probably the warmest period in the last 3,000 years, excepting for the present, the last few decades with greenhouse induced warming. And during that time period, giant sequoias burned the most frequently, and they survived because they were low severity fires. So basically the fire regime responded by having a lot more fires, but they tended to be low severity and really low extent. So the more frequent the fires occurred, the lower severity, low intensity, low flame lengths burning through the understory. So what the lesson there is that as the temperatures warm up, actually it's more important that we reintroduce more fire into these forests of the right kind. And these pine forests and pine dominated mixed conifer forests, low severity fires can impart a resilience to those forests because it reduces the fuels and allows those big old trees to survive the fires that come through. And here's the problem in the sequoia groves where we've lost maybe up to 20% of the biggest trees have been killed in 5 years. It's a stunning figure. Well, the main reason for that is that those forests have grown up with understory canopies of shade tolerant trees. And where the sequoias have survived the best in the groves in the last 5 years is where there's been thinning and reintroduced fire. The groves that have been treated have survived. The groves, the backcountry that haven't been treated, that's where the greatest mortality has occurred.
Thank you, Tom. And I'd like to thank all our presenters. We have Ellis, Craig, and Tom for this webinar. I want to thank everybody who's attended there. And while we have one on the same issue with the values, are we concerned with over desiccation with over thinning for establishment? I didn't catch with the VPD values. Are we concerned with over desiccation with over thinning for reestablishment? It's a weird question.
I can take a shot at that unless anybody else wants to. So I think my understanding of the question is that if you're thinning the forests, then potentially you have more sun hitting the ground, and how does that change, right? How does that change the environment? And this is it's an open question. It's an interesting and important question, because again, we're taking forests that are in this unnatural state, and in some cases pushing them back to maybe a historical state and changing densities through fire and or thinning. And some of the studies that I've seen have shown that that you actually have more moisture and a higher resilience, if you will, to the drought stress, again, in that mixed conifer zone, ponderosa pine zone, basically because there's more resources, there's more water to go around. And so if you have 10 times more trees than you did, historically, then you're sharing, you're spreading those resources that much thinner, and including water, right? Craig's presentation that shows that you're just having more aridity in the system as you crank up the temperature. And so there is indication that stands that are in more of an open state, that there's more resilience to these droughts and even to the bark beetles. There's a really cool study that shows that trees that have experienced fire have resin ducts, more resin ducts than trees that haven't. And resin ducts are one of the primary ways that trees fight bark beetles. They pitch out the resin, right? And so Sharon Hood is the study. It's one of the coolest ecology studies I've ever seen, that shows that as trees are experience fire again, after not seeing fire for a century, that they have more resin ducts and potentially could be more resistant to some of the stressors related to VPD and other things that Craig outlined. But even just directly having more water and resources in these increasingly drier times is something that seems like it's an indication as these stands return to densities we think they were historically.
I'll just say a little more about that. Wasn't entirely clear of the particulars of the question, but there are a lot of variables involved affecting the water balance on a site in these systems. And people have been looking actually at this kind of thing in the mountains, Southern Rockies in the Southwest for decades. There used to be in the 60s and 70s a lot of experimentation where there was actually trying to figure out how to increase water yield out of the mountains when forestry and timber activities were a bigger thing, and that was, they could do that. And more recently, the last couple decades, it's been more about looking at the water balance on the site, although now still wondering how much of it is affecting, as we're seeing the runoff, snowpack runoff relationships changing. But anyway, there's a sweet spot with density. If forests are wall-to-wall, really dense canopies in this climate here, when it snows in the winter, a lot of the snow is captured on the canopy, and it actually, the sublimation is where, when after we get a storm and it clears out and the sun is shining right there at that surface of the canopy, it's warm enough that it goes straight from snow to water vapor to the atmosphere. And similar things happen when you open the canopy, if you open the canopy too much, with how much snow is on the ground. So there's these kind of 40 to 60%, 50%. You go under 30, then it's too open. You get more than 60, it's too dense. So there's a sweet spot in the middle, but it depends on a lot of other particulars. But in terms of just how much of the incident precip, particularly the snowpack, actually is able to melt and become part of the soil recharge and plant available water on that site, and the water that actually can make it into streams is surface runoff as well. But it's not an easy thing. I guess that's what I'm saying. It's not a clear-cut thing, and it's like not thinning is good or bad or whatever. It depends on, like so many things, depends on how it's done. So.
Well, thank you, Craig. I really appreciate that. I really appreciate listening to all three of you talk tonight and kind of tell us about what fire ecology. And I've definitely learned some things. Hopefully our audience has as well. And I think, the Fireshed is going to continue this conversation as we move forward into the new year. I wish everybody happy holidays. And as we move on, we'll be posting those things out. Stay tuned to the Santa Fe Fireshed.org website. Stay on the Facebook page. And as we move forward, as the Forest Service makes plans, but as well as all the partners in the Fireshed have different plans and projects and things that they're going out on there. We'll have things to think about and talk about, and I'm sure you'll be hearing from us again. So I appreciate that. Appreciate everybody joining us tonight. Thank you.